Here is another example of a problem that requires us to create a function, right, in order for us to solve the problem, right? So the scenario is we have cyclist A traveling at 16 meters per second when she sees cyclist B 15 meters ahead traveling at a constant velocity of 15 or 10 meters per second, okay? So that sets our stage for what is going on. We can see that cyclist A, right, we could call cyclist A the position where cyclist A is at the moment. This would be the starting point, okay? And cyclist B is already 15 meters in front of the starting point. So its displacement, or cyclist B's displacement, is already 15 meters, right? Cyclist B is traveling at a constant velocity of 10 meters per second. So just logically, you can work out if nothing had changed, cyclist A is cycling faster and at some point would catch cyclist B, right? Cyclist A, the faster cyclist behind, slows down at it should be implied that it is a constant acceleration of 1.5 meters per second squared. And what we want to do is find the minimum gap between the cyclists. So what we're trying to say is cyclist A sees cyclist B and starts slowing down immediately, right? And because cyclist A is slowing down, at some point, right, initially the gap is going to close, right? But as cyclist A's velocity drops below 10 meters per second, right? At the moment that that velocity hits 10 meters per second, there will be a gap between cyclist A and B. And we want to know what is the smallest gap between those two cyclists, right? With respect to time, okay? So the way we're going to look at this problem is not in terms of the cyclist, we're going to look at it in terms of the gap. We want to work out a minimum value for this gap, right? So we want a function for gap with respect to time, right? And so we can call our function gap with respect to time, okay? And so now we need to come up with an equation to calculate this gap based on the information that we're given, okay? We can see that this gap, right, the gap between the two cyclists is based off three components, okay? We have the initial gap, all right? So we have this initial gap over here of 15 meters, right? And after a certain amount of time, both cyclists would have moved some displacement forward, all right? Cyclist B will have moved this distance here, and cyclist A will have moved this distance here. And we can see that if we want to work out the gap, right, which is this section here, okay, if we take the total gap in the beginning between A and B, if we add cyclist B's distance, and if we take away cyclist A's distance, you can see we get left with the gap, all right? And this is the gap that we are trying to find. So we're basically saying we would like the 15, which is the 15 meters that we're starting with, right? In other words, when we look at time of 0, right? In other words, g of 0, right? At time equal to 0, we are already at 15 meters. That's the gap, right? So this is where this 15 would come from. Now we want to add the displacement for cyclist B. Okay, because we can visually see if we add the displacement for cyclist B and we subtract the displacement for cyclist A, it will give us the gap. Okay, and we would like a function, right, because we would like to find the gap at any point in time. So what we need to do now is we need to formulate two displacements for these two cyclists, right? And because these are happening at the same time, their time is going to be the same. Even though they are not at the same position, these events are happening at the same time. So we're not going to have time 1 and time 2. However, we will have displacement 1 and displacement 2. So let's go and work out the displacement for cyclist B. Okay. What do we know about cyclist B? Cyclist B is traveling at a constant velocity, right? So we just have velocity, and that velocity is equal to 10 meters per second. We know that the time, we want it to be a variable in our equation because we want to take any point in time. So we're not going to solve for t, we just want to keep it in our equation. So this is constant velocity, so I'm just going to use the constant velocity formula. Displacement equals velocity times time. That means the displacement for cyclist B is equal to 10 meters per second times time, right? Whatever time that is. After 2 seconds, that person would be 20 meters, 3 seconds, 30 meters, etc. We can do exactly the same thing for cyclist A. So here we have cyclist A. And what is the information we know about cyclist A? We know the initial velocity is equal to 16 meters per second. We know the acceleration is equal to minus 1.5 meters per second squared because they are decelerating. We don't know any other information. We're not interested in the final velocity, but we would like to have a displacement function, meaning we would like time to be in our equation. Okay? We're not interested in what the time is, but we would like it in our equation. We want a function that could give us displacement for any value of time. And fortunately for us, these events are happening at the same time. So these two times are the same, regardless of where the cyclists are. We don't need to make an equation relating the times of these two cyclists. So the formula I will choose to use here, based on the information I have and what I want to have, is displacement equal to ut plus a half at squared. So we need to now place in the values that we have. So we have displacement for cyclist A equal to the initial velocity of 16 meters per second times time plus a half, and we have minus 1.5 t squared. We can just tidy this up a little bit. We can get the displacement of cyclist A is equal to 16t minus 0.75 t squared. So now we have solved for the displacement for cyclist B and for this displacement of cyclist A. So we're going to create our function, the gap, with respect to time now. So the gap at any point in time is equal to that 15 meters that we started with. Right, we're going to add the displacement for cyclist B, which is 10t, right? This is that 10t over there. And we're going to subtract the displacement for cyclist B, which is over there, which is 16t minus 0.75 t squared. Right, at this point, what we can do is we can tidy things up. Right, this 10t and this 16 on the inside are going to simplify to, we're going to get minus 16, so this is going to become minus 6t, and we're going to get plus 0.75 t squared. Is the function with respect to time for the gap between the two cyclists. Now, let's go back to the question. Right, the question said, find the minimum gap between the cyclists. So we have two routes that we could go down in order to find that. Okay. This is a quadratic equation, right? We know that the minimum value of a quadratic equation is the turning point. Right? We also know that the minimum value for any function is where the derivative, right, or actually in my case, this is not dy by dx, this would be dg by dt is equal to 0, right? In order to find the turning point of a quadratic, we can just complete the square. Right? And by completing the square, you would immediately be given the time and also the gap between the two cyclists. Alternatively, you can differentiate, right? Make the derivative equal to 0. This will give me the time at which the gap is minimum. And using that, we can place it back into the original function to get the gap, right? We can find the point at which the gradient is 0 of the change for the derivative, and plugging it back into my gap with time function, it will give me the gap, right? So I'm going to do both methods. Obviously, completing the square is going to be the fastest way because it's going to give you both immediately, right? But they should both give you the same exact answer. So completing the square, I'm going to pull out that factor of 0.75 because it's just going to make everything very awkward. So if I pull out a factor of 0.75, I will get t squared, right? So I'm dividing by 0.75 effectively. So I'm going to take 6 divide by 0.75. This is going to give me 8. And I'm going to do the same thing for 15, divide by 0.75. This is going to give me 20. Right, now I just need to complete the square. All right, so I'm going to have t minus 4 squared minus that 4 squared plus 20. Okay, so that's going to give me minus 16 plus 20, which is just 4. So we have t minus 4 squared minus 4. Okay, we can now multiply that 0.75 back into our equation. That gives me 0.75 t minus 4 squared. And if we take minus 4 multiplied by 0.75, we get 3, and this is minus 3. This tells me that I have a turning point, right? And in this case, this is a minimum because it's a positive quadratic, right? We have a minimum at the point 4, negative 3. my apologies, this is positive. There was negative 16 plus 20, so that's positive 4, so that becomes positive 3. Okay, remembering we have x and y, except we don't have x and y, we have t and g, right? So the time being my x coordinates, so this is time, and this is the gap, right? So the minimum gap happens at t equal to 4. We have a gap of, we have to go back and look at the units we were given, meters. So we have a gap of 3 meters. Right, the alternative method to this would have been to differentiate the function and to find the value at where the derivative was equal to 0. This would give me the minimum value. Okay, so I'm going to take my function again, and I'll do it in purple or in red to show the difference. So my function g of t is equal to 15 minus 6t plus 0.75t squared, right? The derivative, g dash t, right? We need to differentiate, so we're going to take 0.75 times 2, which is going to give you 3 over 2t minus 6. There's my gradient function, right? And for a minimum, my g dash t must be equal to 0. So let's make it equal to 0. 0 is equal to 3 over 2t minus 6. 3 over 2t is equal to 6. T is equal to, right, we need to divide by 3 over 2. So 6 divided by 3 over 2, unsurprisingly, is going to give me 4. Is my time equal to 4, and now I substitute this value back into the original function to give me the gap, because remember the derivative doesn't give me the gap comes from the original function. So in other words, g of 4 gives me 15 minus 6 times 4 plus 0.75 times 4 squared. And if you do the calculation, this will give you 3 meters. Okay. So you could have gone either route, they would have given you the same. It all depends on your understanding, right? And obviously, like I said, completing the square would have been faster because you got both of them at exactly the same time. But using the derivative is also completely acceptable.